Hello. Good morning. Good morning. So, those of you that are here, anything you'd like me to do? Otherwise, I'm just going to kind of do my own thing, go over all of 2.1 through 2.4 here. So, any questions can go in the chat. If I don't see any questions, I'm going to kind of get started with my thing here on 2.1 and 2.4. Just kind of my own summarization, but okay, admitting people. Okay, looks like we'll give everybody a second here to get in. 228 is the first one that I see in chat here. So let's go ahead and look at 228, instance variables for your dog. Says now we're going to use more instance variables. Here we have a class that represents a dog. Currently the only instance variable or I need to share my screen. Duh. Hello, let me wake up here. Okay, taking me a minute to get going. Let me go ahead and share my screen. That would be helpful, huh? Okay, share my screen. Instance variables for your dog. Okay. All right, here we go. So this says now we're going to use more instance variables. So these instance variables, which you've read about, they are just kind of the way I think of it is the pizza example that's earlier in the unit. You want to think about, okay, if I'm ordering a pizza, what type of things am I able to specify? That's kind of what you're thinking about when you think of instance variables. You know, the size, the number of toppings, the price, all that stuff. It's different pizza to pizza, but every single pizza has those elements to it. So those are the types of instance variables we want to come up with. For this one, it says we have a class called representing a dog. The only instance variable is called breed. You can make a new dog object by passing the breed to the constructor. We want to add an instance variable that's called a string called name, which represents the dog's name. Add the instance variable. Okay. So the view is a little bit different now inside of Code.hs because there's two files. The tester file, the one that has the main method, is the one that's going to be creating the objects and stuff like that. And then you see there's another file over on the left. This one is kind of the blueprint, the one that describes a dog, so to speak. And right now we have one instance variable. We always make our instance variables private. It's declared up at the top. It says add another instance variable here for the name. So obviously the name is going to be a string as well. This is 228. The instance variables for the dog one. And now I want to add another string that represents the name to my constructor. I believe that's what it wants me to do. So add an instance variable called name, which represents the dog's name. Add the instance variable and also include it as the second parameter in the constructor. So this down here is called a constructor. I sometimes think of constructors like object factories. They're the thing that actually allows you to create an object. If you don't have a constructor, it's going to be impossible to make an object. So right now, our constructor always is public, and it always has the same name as the class. So since the class is called dog, my constructor is public dog. If this were a cat class, this would be public class cat up here, and this would say public cat. After that, in the parentheses, you put in basically these parameters, these temporary placeholders that are going to represent values that you're giving to your instance variables. So since we have one instance variable that's a string called breed, we have a parameter in our constructor called string the breed. I'm going to kind of follow this format here and do another instance variable for the name. Now, excuse me, I didn't mean instance variable, another parameter to represent the name. Really, you can name these parameters whatever you want to as long as they don't match the name of the instance variables exactly. So if my instance variable is called breed, I don't want to make a parameter called breed. That's why it's called the breed. My computer science teacher in high school just had us put the in front of the instance variable name to make our parameters names, like I've done here. You could make it shortened if you wanted to. You could just do NM or something, as long as it doesn't match exactly the actual instance variable here. But I'm just going to go with the name, which I'm guessing most people did. And then inside of your constructor, you basically always want to have the instance variable on the left, so breed, equals the parameter on the right, the breed. I'll do the same thing here. My new instance variable is called name, so I put name equals, and then I'm going to put my my parameter, the temporary kind of placeholder variable, on the right side of the equals sign. And then I think that's what I'm doing for this one here. And let's see. Looks like that one is working on my end. If you ever find it's not working, it doesn't pass the test cases, I click this test case one, I'll do check code, and then run it through. It looks like it'll show you kind of what it was expecting and what came out of it. So it looks like I passed my test cases. Let me pull back up dog.java in case there's any questions here on this one. And 228. When I hit check code, it reverses what I see when I run the code and says it's wrong. So if you requested this one, did this help? Do you see what was going on? Were you able to find out what was going on and fix it? Or if anybody else has another question on this one, otherwise I can move on to the next problem. So this is actually a really good problem. I'm glad you guys brought this one up because it's got instance variables up here at the top and also has a constructor down here that we're kind of writing. So if you hit run code, if I hit run code, it's flipped. Like, I guess Sammy is a golden retriever. Oh, so just, I guess if it's flipped, if it says golden retriever is a Sammy, I'm guessing that's what you guys are talking about when you say it's flipped. Make sure that, look at your constructor. The first thing is supposed to be the breed, and I know that the first thing is supposed to be the breed here because also in dog tester, when the object is created, the breed is passed first and the name is passed in second as those actual parameters. So I would just make sure in your constructor, you go in order, string the breed, string the name, and then you use the breed and the name to actually specify the your instance variables there. If they're switched, I'm guessing what's happened is you put string the name here and then string the breed second. So that error would mean that when we run dog tester, golden retriever would be passed in for the animal's name, the dog's name, and then Sammy would be passed in for its breed. So I want to make sure that these are in the correct order. The breed is first and the name is second, and then I say breed equals the breed, name equals the name. But if you put these out of order, here, I'll kind of show you really quick. If I do the name over here and then the breed second, what's going to happen is in dog tester on line 5, golden retriever is still going to be passed in, but instead of it being passed in for the name, now it's going to be passed in for, instead of it being passed in for the breed, it'll be passed in for the name because that's the order I just put it in dog.java. And similarly, Sammy won't specify the name. Sammy will be passed in for the breed. So now this will say golden retriever is a Sammy if I run it like this. So that's where the reversing would come in. You just want to make sure that the first one represents the breed, and then the second one here represents the name. Does that answer question there, Hayden? And everybody else. But basically, the order that you put these parameters in here, when you say new dog, golden retriever, comma, Sammy, new dog will get passed in for the breed and Sammy will get passed in for the name. So just making sure we have the order correct there. All right, cool. Other requests. 238. Let's look at 238 method overloading. Okay, let me go back here and pull up 238. Give me 1 moment. Overloading is definitely something that's a little tricky, but I think the Code.hs does a decent job of demonstrating overloading in the context of the different constructors. So 238, let's see, make sure I get the right one here. Custom pinatas, perfect. I actually had this one on my list to do, so I'm glad we're going over it. Give my computer 1 second. The AOL's connecting here, dial-up internet. Okay. I'll just put it in the assignment tab here. Okay, it talks about what a pinata is if you don't know what a pinata is. So there's that. The class only has a constructor without parameters. So if I go ahead and look at pinata right now, up here, instance variables, I've got 3 of them, string representing the candy that's inside of the pinata, I assume, a string representing the color, and a string representing the shape. What that means is for each pinata we make, it's gonna have a candy, it's gonna have a color, it's gonna have a shape. Now, one of them could be Snickers, blue, and an alpaca. Another one could have Twix, and it could be yellow, and it could be a horse. You know, all these pinatas are going to have those instance variables, but they could be different from pinata to pinata. We're just saying that those 3 things specify them. So it says, note the additional constructors. Okay. After you make constructors. Okay. So what you're doing when you're writing a method that's overloaded is you have methods that have the same name, like public pinata, for example, but then they take a different number of inputs, or AKA a different number of parameters. In this case, right now, we have one constructor for pinata that takes in no parameters. That's where it says constructor without parameters. This one has nothing in the parentheses. And it's just going to kind of quick and dirty make a really fast pinata that contains hard candy, its color is rainbow, and shape is donkey. And anytime I just say new pinata without anything in the parentheses, it's going to make this exact pinata. I often think of a default constructor or a parameterless constructor like this one as kind of like character creation in a video game. When you say, boop, create a character, they kind of have that one like nondescript character spinning around, and then you go ahead and you specify, you add on like a beard and all that kind of stuff. And change their statistics and change their eyes and all that stuff. But a default constructor just allows you to quick and dirty make an object. Now, if I look at Pinata Tester, right now I see that Ella makes a pinata, and on line 6 there's no parentheses. So Java knows to go and find the constructor that has no parentheses when I just say new pinata with the parentheses empty. I also see that there is a pinata named Pete, and Pete looks like he gets a candy, a color, and a shape. So right now, those are 1, 2, 3 different parameters. If you look at pinata.java, I don't have a constructor that expects 3 different parameters representing the candy, color, and shape. I only have this one constructor that expects no parameters. So I'm going to write another constructor down here. Our constructors are always public. They always have the same name as the class. So since the name of this class is Pinata, I'm going to put public Pinata. And at this point, you look at these 2 constructors and they're the exact same. Java cannot differentiate between them because this one has no parameters and this one has no parameters. The way we can tell Java which one we want to call is by changing, basically when you're overloading a method, like we're overloading the constructor here, you have a method that has the same name, except the parameters are either a different order or a different type. So in the case of Pete, we're supposed to make one that takes the candy, the color, and the shape. So just like the last activity we did on the dog, I'm going to go ahead and have a constructor that takes in, I'm just going to kind of go with the formula we did with the dog class, string the candy, string the color, and string the shape. Now, I need to make sure that those are in the right order there. If I could pull this over, I totally would. Maybe if I make it smaller slightly. Hope you guys can still see that. Okay, you would tell me in the comments, hopefully, if that's not okay. I got to make sure that this is in the right order. Candy, color, the shape. Let me look back at Pinata Tester. This represents the candy, this represents the color, this represents the shape. So I think those are in the right order now. Kind of like the dog problem previously, I want to make sure, you know, that I've got them in the correct order, because Java doesn't know that hard candy represents a candy type instead of a color. The only way that it knows is the order that we send them in. And so the first one's going to represent candy, the second one's going to represent the color, the third one's going to represent the shape. And just like the last constructor, I always do the instance variable name equals the parameter name. The instance variable name equals the parameter name. The instance variable name equals the parameter name. So that's one that's going to work for Ella or Aya, or excuse me, for Pete, pardon me. Pete the Pinata on line 7, 3 strings representing candy, color, shape. And if you look back at pinata.java, candy, color, shape for that constructor. Now, how does Java know which one to call? Well, this is, again, what method overloading is all about. If I say create a new pinata and I don't pass in any parameters, like we see on line 6 here, Java's going to go find the constructor that expects no parameters, the one that's written right here. On the next line, when Pete is created, Pete sends in 3 different strings. And so 1, 2, 3 strings, Java will now go and find the constructor that's expecting 1, 2, 3 strings. And that's the idea behind method overloading. Methods that have the same name, you can differentiate between them by changing the type or the order or the number of parameters, essentially. So these two are differentiated because this one takes no parameters, while this one expects 1, 2, 3 parameters. And then I think I have to keep going here. There's one I see on line 8, Sweetie's created, and Sweetie only has 1 parameter, and it looks like that parameter represents just the candy type. Sour straws are a candy as far as I understand here. You know, so there's a couple different comments here that tell me which constructor to write. I'll do the one it tells me to write right here. This one says, write another constructor, an overloaded constructor that allows the user to customize the color and shape. So I'll do the color and the shape. That one only has 2 strings representing the color and the shape. So I'll say something like color equals the color, shape equals the shape. And notice again, I'm doing instance variable on the left, like candy or color or shape, and then the parameter, the color or the shape on the right. Now, this one's not quite done yet because it'll set the color, it'll set the shape, but then what's the candy going to be? I don't have anything specified for what the candy is. So you can go ahead and just go in and give the candy some default value. I'm just going to use the same default value that was up here. Now, does the order matter? Does it matter if I do line 29 on line 27 and flip-flop them? No, because it's going to go ahead and specify all 3 of those. But you do want to make sure if a instance variable is not being parameterized, that at least you give that instance variable a starting value. The last one, so actually I don't think this constructor is called because there's 2 strings being expected by that constructor. And if I look at Pinata Tester, no strings, 3 strings, 1 string, that constructor is not even being used. So what's the point of writing a constructor when you're actually not going to use it? Well, I don't know, do you guys have tools in your house that you don't use every day? Maybe someday you'll end up using it, or somebody else in your company is going to use it at some point. So it's always good to write a good amount of constructors here. Last one, it says add an overloaded constructor that allows the user to customize the candy only in this case. So if you look, we've had a constructor that expects no parameters, 3 parameters, 2 parameters. Now, obviously, this last one, I need to differentiate it by having it only expect 1 parameter. And here it says this one's going to customize the candy. So I'll go ahead and say candy equals the candy. Again, instance variable on the left, parameter on the right side of the equal sign. Now I don't have values again for the shape and the color. So I'm just going to use the shape and the color from the default constructor. Don't believe me? Watch, I'll copy and paste it right here. And so I'm just using those default values that were already in the parameter list constructor. You could change them, I suppose. But here on this one, it says just specify the candy. So the candy specify on line 35. Line 36 and 37, I'm going, oh, well, if I didn't specify the color and the shape, I need to come up with actual values for the color and the shape. And so I'm just using ones from the default constructor. So going back, what is method overloading? It's when methods have the same name and return type, which we'll get into, I think, next week. But they have the same name, pinata, pinata, pinata. But then they have a different type or a different type or different number of parameters. In this case, we have 0 parameter constructor, 1, 2, 3 parameter constructor, 2 parameter constructor, 1 parameter constructor. And again, Java knows the difference between them based on how many parameters you pass when you actually call them. On line 6, nothing in the parentheses, so Java knows to find the constructor that expects 0 parameters. Line 7, constructor that has 3 string parameters. So Java goes and looks at the constructors and goes, oh, this one named Pinata expects 3 strings. So I'm going to call the one with 3 strings. Line 8, this one only has 1 string. So Java knows to go and find the constructor that only expects 1 string and use that one. That's method overloading in essence. And Java can differentiate which one you're trying to call based on the number and type of parameters that you pass in when you call it. So looks like I'm good there. I'll just put up Pinata again. Any questions on this one? Or method overloading is definitely a little bit it's tricky. Is there another one maybe from this section, or maybe we have questions on this one? 239. Perfect. 239. Let's look at 239. I'm guessing it's kind of along the same vein here. If you guys are okay, I'm going to continue. I am recording this, so if you miss anything, you know, you could always take a shot with your what do they call those pictures? You could always take a picture with your phone too if there's something you can't get down fast enough. Okay. 239, more on method overloading, hopefully more on method overloading. I'm not calling it more on method overloading, just more on. Okay. Okay, let's see. I'm just going to pull it into the assignment here. Every web page has an address. A web address is made up of a couple of different pieces. Okay, so codehs.com, HTTPS specifies which protocol. CodeHS is known as the domain, and com is called the top level domain. Okay, we typically refer to, okay. Your job is to implement a class that represents a web page address. It should have the following instance variables: domain, top level domain, and num users. Okay. The class needs 3 constructors whose signatures are shown below. So I'm going to just kind of dive in here and get started at this beginning. I've got 2 tabs over on the left. I've got website and website tester. I'm going to be writing my code in website.java. Tester files, these 2 files kind of work together. And the way that they work together is website.java is the class. It represents in this case, website. It's like a blueprint. And then website tester is the one that's actually going to create website objects and call methods on them and so on and so on and so on. So I'm going to click on website.java here. Usually up at the top, we do our instance variables. So I'm going to follow that convention. Private string top level domain. Sorry, I'm typing a little slow today. I've got my laptop on like risers because they said that this angle is the best for. Okay, so I've got my instance variables up at the top there. They're declared. We always make them private, and I'm just using the format they told me to do here. The class also needs 3 constructors. I hope nobody minds here, but I'm just going to copy and paste this, and then I'll fix it. Oh, that worked well. Said nobody. Give me 1 second here to fix the formatting. What's that saying? Show God your plans and he'll laugh. Something like that. Okay, here we go. All right. Default constructor, aka our parameterless constructor. I see that one first here. So these are three overloaded constructors. How can I tell? This one has no parameters, this one has 2 parameters, and this one has 3 parameters. And so I can't make another one that has 2 strings. I can't make another one that's parameterless because then Java is going to get confused. You can only have one that essentially has the same, what we call the method header, this first line. So, forgot that adds the braces, that's nice. Then I got rid of it. Okay, this first one here for website, it says the default values should be for domain. What's domain versus top level domain? Domain, top level, okay. So it says make top level domain should be com. Domain should be an empty string, just quote, quote, and num users should be 0. If you're wondering where I'm getting that information from, it's just this little paragraph over here. And in any other constructors I write, if they're, for example, in this next one, since there's no int representing the number of users, I'm going to specify it to 0. If there's no string representing the domain, I'm going to use this. If there's no string representing the top level domain, I'm going to use com. So that's my default constructor. I'm just using the instructions they have here. The next one looks like it takes in 2 strings, and I can easily tell what they're representing based on these variable names. The domain name, I'm guessing, represents the domain. So I'll say instance variable, domain on the left equals the parameter, domain name on the right. And then top domain, I'm guessing represents top level domain. So I'll say something like top level domain, that's the name of my instance variable declared up here, equals top domain. And then I look at this constructor and I go, oh, they didn't specify the number of users. There's no parameter for the number of users. So I'm just going to use the default value up here, num users equals 0. Don't be shy to copy and paste there. So that's an overloaded constructor. Again, it has the same name, public website, but different number of parameters. So Java knows that when I send in no parameters, they'll call this first one on line 9. When I send in 2 strings, it'll call in this one on line 17. This last one here takes in parameters for all 3 of the instance variables, the domain name, the top level domain name, and the number of users or number of people. Now you'll notice here, they kind of changed the format they went with for their parameter names. That's fine, as long as you can tell that this represents the domain and that this represents the top level domain and that this represents the number of users. So inside of here, I'll go ahead and say domain equals domain name, top level domain equals top domain, and num users equals num people. And I don't need to specify anything else because we only had 3 instance variables, and there I've got all 3 of those instance variables being specified. So I don't need to put in any default values at this point. It says create at least 3 objects. So this is the class, essentially. The class is done here. And then I'm supposed to go ahead and actually I'm supposed to go ahead and make some objects. Sorry, I just totally spaced out. Let me get a drink of water really quick. I'm going to create the objects in website tester.java, so I'll click on that tab in 1 second. Excuse me, streamer, that was 5 seconds. Okay, let me click on website tester here. So whenever I create an object, this is great to bring up. The format for creating objects is you always do class name, followed by, actually I'm going to put this in a comment here. So you always do class name first, like scanner, like website, like pinata, whatever. Then the name of your object with the lowercase, because it's a variable name essentially, equals, and you put the keyword new, and then the name of your class again, which is essentially calling your constructor, because remember, the name of your constructor is the same as the name of your class. And then in parentheses, any required actual parameters. And if there's more than one of them, you go ahead and you separate them with commas. And this is where you actually put in real values instead of just using variable names. So you can put numbers if your constructor expects an int. You can put strings inside quotations, string literals if your constructor expects strings. So I'm going to create the objects they requested here. Name of my class is website. I'm going to call this object site1. And it looks like it's created using the default constructor. How can I tell? Well, it looks like that the domain is nothing. It's an empty string. The top level domain is com, and number of users is 0, which is what we already used in our default constructor here. So I'm just going to say equals new, and then the name of my class again, website. Since I want to call the default constructor, you notice that the parentheses are empty. I don't want to send any extra values in. Then I'll make, well, you know what? Let me just go ahead and print it out to show you if it's working or not. How about that? Spinning wheels. I think that's what they wanted it to look like. So you see that it defaulted this to empty, and it used com as the top level domain, and number of users is 0. Then I'm going to go ahead and make the other 2 websites that they're asking me to make over here in that highlighted section. I'll go ahead and do website, maybe I'll call it site 2. I'm not a creative person, clearly. In this one, it looks like they are specifying the domain and top level domain, but not the number of users. My screen went black for you. Let me try something really quick. I'm going to stop sharing my screen with everybody, and then I'm going to resend it. Let me try this again. Give me one moment. Share the screen again. Let's try now. Is it back for everybody, for anybody? Is it working now? Let me know in the comments. Okay, website 2 looks like I'm just specifying the domain and top level domain, or domain name and top level domain. Looks like I've got a constructor that does that right here, and I'm supposed to specify those to good school and .edu. So I'm going to go ahead and what order was it again? Domain, top, okay. So I'm going to do in order good school and then edu. I don't think I have to put the dots there. Let's just double check. Hayden, hopefully my screen's working again. I don't know, let me know if it's not. Now, going back to the dog problem we did a few minutes ago, if I were to switch these, if I switch this to edu and I switch this one to good school, take a second, think about what's going to happen. We good? Is it working? Okay, no? All right. So if I switch those, it's going to call the constructor, but it's going to send an edu for the domain name, and it's going to send in good school or whatever for the second part. And so I'm going to get an issue at that point where it switches them, kind of like we saw in that dog problem a little bit ago. So now it says www.edu.goodschool. So you just want to make sure that you always look at your constructor and the order of stuff that your constructor expects. Here, my constructor expected the domain name followed by the top level domain. So when I create an object using that constructor, I better darn well send them in that order. And the last one here, it looks like we're specifying the domain, top level domain, and the number of users. So that would be my third constructor here, because that third constructor has domain, top level domain, and the number of users. So I'm going to go ahead and make one more here, site 3. And let me just look back at my constructor. My constructor expects domain, top level domain, and number of people, and I have to send them in that order. Okay, thank you. I'm glad it's working now, Hayden. Thanks for letting me know. I appreciate that. Sorry that was going on there. Looks like code HS is the name of the domain. Top level domain is .com. And then it looks like the number of users, how many zeros? 6? 1, 2, 3, 4, 5, 6. You'll notice I don't put any quotation marks around a million because it's not a string, it's an integer. So then I go ahead and print out site 3. And let's just see where we're at. And it looks like that one is working for me now. So again, how does Java know which constructor to call? Well, it depends on what parameters you send in the parentheses. It's all dependent on what parameters you send in the parentheses. Here, if I put nothing in the parentheses, Java knows to call this constructor. In the second one here on line 17, if I send 2 strings, it knows to call that constructor. So you can see here I sent 2 strings, so Java knows to call that constructor. And then third, if I send in a string, and an int, Java knows to call this constructor on line 25, string, int. So that was a great question. We got to talk about constructors, overloading methods. We got to talk about how to create objects as well and how those 2 files are kind of working together. Remember the .java one, website.java, is just kind of the blueprint. It represents what a website is. And then website tester is the one that actually creates objects and calls them methods. Questions on that one? Good question so far. Other ones? While people are thinking, maybe typing, I just wanted to say really quick, you guys are all doing a fantastic job. I know I put it on the Google Classroom, but like an incredible number of people are up to date, turning stuff in, and looks like going through these. Again, I chose CodeHS because I know you guys are busy. Some of you might be, working, donating your time, being an essential worker, all that stuff, which is great. And so the nice thing about CodeHS is that you can kind of do it whenever you can do it. And so that's called asynchronous. The meeting we're having right now is synchronous because we're talking at the same time to each other and communicating. But that asynchronous nature, a lot of online classes are asynchronous in nature. So it's also just good preparation for the future. And you'll probably take classes in maybe high school or college where you'll do it online. I know my whole master's I did online. I never met anybody in person, except to like pick up my diploma. So it's just good practice for that. Any other questions? I'll give you guys another minute here. If there's not any questions, I'm gonna work through an example that I've created. You can hang around and watch it, or you can take off if you're not interested, but I'll record it. But I was just gonna do an example if nobody has any. Yes, good question in the chat. If you're a little bit behind, that's okay. Get caught up. I'll try to update in the gradebook. But if you don't see an update in the gradebook, just shoot me an email saying, hey, Mr. Foster, I got caught up on CodeHS stuff. And I can put it back in the gradebook. With that being said, going forward, you do want to stay on pace week to week because those aren't, don't think of, sorry, I said gradebook. Don't think of Power School as like a grade book right now. Think of it just as like you were in elementary school, like you sticker, smiley face, whatever. Are you doing what you need to be doing? I'm just supposed to keep track of who's participating week to week. So if you're behind right now in week 3, that's okay. But like going forward, I need people to stay on task because I'm supposed to chart participation week to week. So if you're a little bit behind, that's okay, but going forward, need to get caught up and get moving. This unit is spread out over 3 weeks, so you should have some time actually in the next couple weeks um, to do that. So good question there. All right, I don't see any further questions. So it's 11:40. I'm going to do my own example here that I came up with, a little person class that I thought was well aligned with sections 2.1, 2.2, 2.3, 2.4. So I'm going to do that example. If you want to hang around and watch, you can. If you're good and want to go work on the Code HS stuff, you can do that as well. Trust me, I will not be offended. It won't be held against you, anything like that. So if you're taking off, thanks everybody for checking in. I'm just going to do an example that I'm coming up with that's not related to Code HS. So if you want to take off, you're more than welcome to. But thanks for checking in. So nice seeing so many of you. Really gives me the energy to keep going, and it just makes me miss you guys too. But I hope everybody's truly doing well. So if you're taking off, adios. I'm going to try to do this example in about 20 minutes here. So I'm actually going to, so again, you're free to go if you want. You can stay if you'd like to as well. I'm going to make a program called Person. And this one I'm going to go through the stuff that's in 2.1, 2.2, 2.3, and 2.4, the stuff that's assigned this week as much as I can. So I'm actually going to make a new file, and I'm going to call it person.java. Hopefully it lets me name it person.java. Oh, thank goodness. Okay, so first things first here, whenever I'm writing a new, so I want to make a program that represents a person. And these people are going to be represented by a name, which is a string, obviously. They're going to be represented by their age, their height, and their weight. And I'm going to do age in years, obviously. Height I'm going to do in number of inches, and weight I'm going to do in pounds. And so whenever we're writing a new class, I always say public class, and then the name of your Java file should represent the name of your class. So person.java is going to represent the person class. Usually CodeHS takes care of that stuff for you, but since I started from scratch here in the scratch pad, I'm just going to do that. So this line 1 is called a class header. Basically, all the instance variables, your attributes for a person, should go inside of here, as well as any methods, the abilities of a person. And so I'm going to do my instance variables first. And here I said a person's going to be represented by a name. We always make our instance variables private, so private string name. If I want them to have an age, private int age. If I want them to have a height in inches, I'll do height as an int, and then maybe private, I don't know, is weight usually a double or an int? Maybe I'll do double for the weight, who knows? You know, the scale says point something on it usually. So we always do our instance variables up at the top. This is from section 2.1. Your instance variables are essentially what is every instance of this class going to have in common. Every person is going to have a name. Every person is going to have an age. Every person is going to have a height and a weight, but those things could be different. That's what instance variables are used for. If you're making a rectangle class, you do length and width. If you're doing a triangle class, maybe it's leg 1, leg 2, leg 3. A circle probably would have an instance variable for a radius. A pizza would have a type, topping, size, price, stuff like that. So in 2.1, they talk about instance variables. And so I've got some instance variables here saying every person is going to have that stuff in common. So that's kind of what's going on in 2.1. Let me just double check my notes here. In 2.2, you talk about constructors. And constructors are, again, I kind of call them your object factories. They allow you to make objects. Otherwise, this is going to have no utility making this person class. I can't use it unless I write constructors to make the objects and then write methods to use the objects and do stuff with them. So we just spent a lot of time in this going over constructors. Usually you start with what's called a default or a parameter list constructor. And that one takes no parameters, and essentially you, the programmer, get to choose values for the instance variables. Essentially, what would you want the default starter person to be in this case? Maybe I'll name them John Doe. Maybe I'll make their age 0. Maybe I'll give them a height of 0 and a weight of 0.0 or something like that. Just a kind of a default starting person. Like if you were playing a video game, you go into the character creator, they have that like very amorphous amoeba-like person that's spinning around with no facial hair, no definition to them. And then later on, somebody could go ahead and change that stuff. That's a parameter-less constructor. And just, no, that's okay for right now. So that's one constructor. And if I wanted to actually use it, I'll go back to my program.java, and to create a person, you learn about this in, I believe, 2.3. Let me check my notes. No, this is still 2.2, creating objects. I put this in the last thing we were doing, activity, but to create an object, you always do the name of the class, then the name of your object equals new name of the class, and then any required parameters. So in this case, I'm doing person. Maybe I'll just call it P1 equals new person. And since my constructor expected no parameters, it's got nothing in the parentheses, I can go ahead and do that. Send nothing in the parentheses. So if I were to go ahead and run it at this point, I don't have any print statements, so it's not going to do anything. But there you go. That's object creation. So that's kind of 2.1 and 2.2. In 2.3, you learn about overloaded constructors. Essentially, these constructors allow you, or overloaded methods, they allow you to write more constructors where people can actually specify the name, the age, the height, and the weight. Really quick before I do that, don't mind me. I'm just going to write a method called toString really quick. You've probably seen this in some of the other examples. Don't worry about this too much here. Name plus, how do I want to format this? Name plus, I'll do a space, comma space, plus age, plus I'll do comma space, plus I'll do height. What would that be? That's in inches. And then I'll do comma space, and then I'll do the weight, and that's in pounds. Okay, don't mind that. I'm just gonna do that so you guys can actually see these working together. Let me just show you that this is creating my default person really quick. Seriously, don't mind that toString code. It's just so I can test it. So there we go. So maybe I'll say years old. 1 second. Age, years old. Okay, there we go. So that'll look a little bit better. Now I can actually show you that I'm creating the objects I'm saying I'm creating. Okay, there we go. Yeah, I know I need a space over there. I see it. I see it. Give me, just, would you? Okay, 1 second. There we go. All right. Sorry for that delay. Next, 2.3, you learn about overloaded methods. I'm going to write some overloaded constructors here. Maybe I want a constructor where somebody can actually specify the name, the age, the height, and the weight. So for overloaded methods, or in this case, overloaded constructors, they start out looking very similar. But the way that we differentiate these overloaded methods is we change the number of parameters. This one was parameterless. It had nothing in the parentheses. Let's write one that's going to specify all 4 instance variables. So maybe string, nm for short for name. This is kind of how I name my parameters. For age, I'll do, I don't know, ag. For height, I'll just do ht. And for weight, I'll do double wt. You can name your parameters here whatever the heck you want to, as long as they're not the exact same name as these. You can notice that I name them and CodeHS names them in a way that you can tell this corresponds to the name. This corresponds to the age, this corresponds to the height, this corresponds to the weight. Why do you do that? Well, so that when somebody's actually calling your constructor and wants to make a new person, they can do that easily and figure out what order they're supposed to be in. Inside of a constructor, if it is parameterized like this one is, I want to always have the instance variable on the left, name, equal the corresponding parameter, nm. Age equals ag, height equals ht, and weight equals wt. So now this is an overloaded method because we've got two constructors. This one here took no parameters. This one here takes a string, an int, and a double. And so how is Java going to differentiate? It's going to differentiate. It's going to know which one you're calling based on the number of parameters you set. So now I'm going to make another person. And it looks very similar to line 7 at this point, except now I want to call my second constructor I just wrote on line 17, and that one expects a string, an int, and a double. I'm going to send it a string, an int for height. What's a reasonable height? Like 5 feet is 60 inches. I don't know, 65. That's 5'5". That seems like a reasonable height. Not trying to judge, not trying to short shame, tall shame, or anything in between shame. Just probably like close to an average there. I don't know. Not that there's anything right or wrong about being average. I don't want you to misconstrue my words, please. And then the last one was weight. I don't know, 200 pounds. That seems reasonable. And then I can go ahead and print out this guy as well. So now I've made another object, and Java knows which constructor to call because in this first one, no parameters. In the second one, 4 parameters. Here, string, int, double. So Java goes and finds a constructor that expects string, int, double. I could make other constructors, but hopefully from the other examples we've done earlier, we kind of get the hang on overloaded constructors. And so that's kind of 2.3, these overloaded methods and stuff like that. Lastly, 2.4, you get into actually calling these methods, void methods. Void methods are methods that basically, well, actually, let me take a step back. What are methods? Methods are the abilities of your class. What can your class do? If the instance variables are the attributes, what kind of data is associated with your object? The methods are what your class can do. Can it run? Can it walk? Can it talk? Can it eat? Can it chew? Can it sleep? Can it whatever? I'm going to add in some void methods. What are void methods? Glad you asked. Void methods are essentially methods that always contain the word void up here. And they just usually print something to the screen, or they maybe modify an instance variable, but they don't actually give you anything back, like a function. Something goes in, something comes out. Void methods, nothing comes out, just usually output or some small change in the object state or something like that. So I'm going to make one called greeting. And for this method, I'm just going to have it print out a greeting. Actually, you know what? Let me call this one print greeting. And so I'm just going to say, hello, name, how are you? Or something like that. Or hope you're having a good day. So I'll do something like print out hello, comma, and then I can add on their name. And then maybe after I do their name, I can do something like print out period, hope you're having a great day. Something like that there. And sincerely, I mean that. So there's a method called greeting. What is name? Name is the instance variable, whatever we've named this person. And so that's an example of a void method. It's just printing out some stuff. Mine's going to say, hello, blank. Hope you're having a great day. Now, in 2.4, you also learn how to call these methods. The way that you call any method is you do, to call a method, you do the object name dot method name, and then inside parentheses, any required params. So in this case, I'm going to do, maybe I'll do a greeting for my first person. P1 dot greeting. What was it? It was print greeting, excuse me, print greeting. And you'll notice that print greeting, no parameters. So when I call it, no parameters. And now I should see, hello, John Doe. Hello, John Doe. Hope you're having a great day. If I do p2.printGreeting, it's going to call the print greeting method, but on my p2 object. And so it's going to use p2's name to print it out. So now if I run it, you'll see it still prints out, hello, John Doe, hope you're having a great day. And then when I do p2.printGreeting on line 15, it says, hello, Bob, hope you're having a great day. So those are examples of calling a method. You do the name of the object dot the name of the method. Does it look familiar? It should. Didn't you guys do stuff like input.nextInt? Then we do stuff like input.nextDouble, input.next line. It's just, that's the same thing. Except I guess those methods are not void, but don't worry about that. Not a big deal right now. You can write other methods. Maybe I'd have a method to calculate and print their BMI or something. Public, you don't know what BMI is. There's body mass index. It's kind of a number that tells you if you're healthy or not. Don't trust the numbers. Print BMI. How do I calculate BMI again? I'm glad you asked. Let's look it up really quick. How to calculate BMI. Kilograms divided by meters squared. That's not what I wanted to hear. How about with feet? How about with inches, pounds, inches? Maybe it'll give me a calculation. Okay, what is this? Give me the picture here. You take the pounds times 703 divided by the height in inches squared. Oh, it's that simple. Pounds times 703 divided by height squared. Okay, we can do that. So going back here, maybe I'll make a double representing the BMI, and I'll do, what was it again? Weight times 703 divided by height squared. We don't really know how to square height yet, so I'm just going to do height times height. And then maybe I'll have a print statement, something like your BMI is, and then I'll have it print out BMI. And so what does that look like? Well, if I want to call the print BMI method, I use whatever object. If I want to figure out the BMI of John Doe, I'll do p1.print BMI. Is that what I called the method? Yeah. And so here it'll print John Doe's BMI. I'm guessing 0 because, oh, nan. What's nan? Not a number because I divided by 0. Sorry about that. What if I do p2.print BMI? This is our buddy Bob. Bob has a BMI of 33.28. I don't think that's the number that you want to see there, but looks like there's that one. So I've written a couple void methods, and again, how do you call them? You do the object name dot the method name. Lastly, you can call methods inside of methods. Maybe I have a method called doctor's office or something like that. Public void print doctor. How about that? Let's say you go to the doctor's office and he gives you a greeting and he tells you your BMI. Hopefully in that order. I can call the print greeting and print BMI methods from inside of this print doctor method. And so if I do that, check this out. I'll do p2.print doctor. Is that what it was called? Yeah. So now it says, hello, Bob. Hope you're having a great day. Your BMI is 33.2, blah, 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 blah. How does that work? Well, when I call p2.print doctor, basically everything in this my program main method freezes. It goes over to person.java and it calls the print doctor method. And so the stuff between the curly braces here in print doctor will happen. What's inside the curly braces? Well, a print greeting. So now it goes over to this print greeting method and it does all the stuff in between these print greeting methods while the main method in my program is paused, while print doctor is currently in stasis because print greeting is doing its job. Basically, think of it as a kind of a really junky assembly line. Don't think of it like Henry Ford's assembly line in Greenfield Village. Think of it as an assembly line where only one person can be doing their job at a time. That's kind of what's going on here. So my program is currently frozen. Print doctor is currently frozen, waiting for print greeting to do its job. Print greeting finishes its job. It comes back to print doctor. Print doctor calls print BMI. So then print doctor is frozen again, and print BMI does its calculation and print statement. When print BMI is done, it comes back to print doctor. There's no more lines in print doctor. So then we go back to wherever print doctor was called, which was back here in the main method of my program. And then since there's no more lines in the main method of my program, that would be the end of my program. So that is 2.1, 2.2, 2.3, 2.4, quick review of everything. 2.1, we talked about what instance variables are. They're the attributes of your class, what describes, what data is associated with a person in this case. And then this is the class header up at the top. You always use a capital letter for your class headers, and they're always stored in a file of the same name. Person is stored in person.java. And then in, let me just check my notes here, check the time as well. Okay, last minute. In 2.2, you learned about constructors and how to call them. Here I'm calling the constructors. I'm creating objects by saying class name, object name equals new class name, and then any required parameters. To write a constructor, I've got an example of a constructor here. Basically, you always make your constructors public. They always have the same name as the name of the class. And basically, they're just used as object factories. They create objects, and you specify your instance variables. In 2.3, you learned about overloaded methods. I used overloaded constructors to explain that. Basically, overloaded methods are methods that have the same name, public person, but then a different number of parameters. This one has no parameters. This one has 4 parameters, a string, an int, and a double. They're methods that have the same name, but different either amount of parameters or type of parameters. And so these are examples of overloaded methods. How does Java know which one to call? Well, based on the number of parameters you send. This one has nothing in the parentheses, so Java calls the constructor with nothing in the parentheses. This one has a string, an int, and a double, so Java calls the one with the string, an int, and a double. So that's kind of overloaded methods in a nutshell. And then lastly, in 2.4, you learn about methods, both calling them and writing them, void methods. And so I wrote some void methods here that just kind of calculated or printed some stuff out. And then to call a method, you do the name of the object dot the name of the method and then any required parameters. So if I want to call print doctor on object P2, I do P2.printDoctor. So that's kind of 2.1 through 2.4 in a nutshell. Thank you for joining me. Have a great day. Have a great rest of your week. Shoot me an email if you got any questions, or I've got some times tomorrow as well if you want to set up an appointment. Thanks for the clapping hands. I appreciate that. You all have a great day, and I will talk to you soon. Adios.